Einstein's theory of special relativity is a universal law. Energy is always equal to mass times the speed of light squared. It might seem odd to say that. To loads of people, it would seem self-evident that Einstein's laws would be universal, but the way people are taught can be confusing. As young children, people are often taught that energy can take different forms so that they can start off on the road of scientific discovery. Indeed, one of the greatest scientific breakthroughs in history came from James Joule realizing and showing that heat and mechanical energy are the same thing. What special relativity says is that energy and mass are interchangeable. It is implicit in special relativity that you know that energy is energy and nothing else. Kinetic, potential, electrical, mechanical, thermal, all kinds of energy are just energy. Special relativity says it can be expressed as mass changes, and that mass changes can be expressed as energy. That said, we are talking about nuclear physics, so we are only really interested in two types of energy: binding energy and mass. Binding energy is the energy used to hold together a nucleus. Mass energy is the energy stored in a particle. The hydrogen nucleus contains one proton. The energy in this nucleus is the mass of the proton times the speed of light squared. The helium nucleus contains two protons and two neutrons. Measuring the mass of two neutrons and two protons individually and separately gives a mass more than the mass of a helium nucleus. The difference in mass is the binding energy. One proton has a mass of 1.67262178 by 10 to the minus 27 kilograms. One neutron has a mass of 1.67492735 by 10 to the minus 27 kilograms. Two of each gives a total mass of 6.6951 by 10 to the minus 27 kilograms. The mass of a helium nucleus is 6.6447 by 10 to the minus 27 kilograms. 5 by 10 to the minus 29 kilograms less massive than its constituent parts. This mass difference has been converted to binding energy using special relativity converting to electron volts. See earlier podcast. The binding energy is about 28.3 mega electron volts. This is a phenomenally large amount of energy. The comparative chemical energy of removing one electron from a nucleus of hydrogen is only 13.6 electron volts. However, this 13.6 electron volts still gives a loud bang if you have a balloon full of it in oxygen. Now imagine the same mass of protons and neutrons combined together to form helium. This is called a hydrogen bomb. Combined together, and the separate nucleons together, is called nuclear fusion, and is the process that occurs at the centre of stars.